Hey everyone, here's a video for you to watch to get a little bit of a better understanding about some concepts around measurement and error. So, the essential question for this video and this topic is how do we measure variables, record our data, and then estimate the error in our measurements? So, a couple of measurement tools that we have. I'm going to put a couple of these up. So, when we want to take measurements for time, this is something that you guys are used to. Stopwatches, phones, something called photo gates, where you can actually like use photos to actually tell how long things are passing. Then we've got mass. We can use scales. We can use force probes. That's something we use to measure how strong a force is. And then we could also use balances, like triple beam balances. The main ones for time and mass that we're going to be using is probably for time, it's stopwatches and your phones. For mass, we may use scales or force probe piece that I'm telling you guys about, but it's a very simplified version of that. And then energy, it's actually pretty tough to measure directly. So when we get into the world of energy, we'll talk a little bit more about that. Anyways, so yeah, sorry I didn't put those pictures up for you first. But yeah, those are a couple of measurement tools we can use, and we'll kind of share more of that throughout the semester. So, when you're setting up a data table, there's certain things that you need to include in your data table so that it's complete and so that you can actually use it in a useful way. So you have to have your columns, the ones that go up and down, like time, mass, like all the different types of masses, actually, and average mass. You have to label those columns so we know what you're talking about. So for the leftmost column, we put time, and then we put the units in parentheses. That's very important because your time could be in seconds, hours, minutes, but in this example, we're looking at days. Same thing with all the mass and the average mass for all those. The other thing is you need to always have enough data points to be able to see some type of trend when we actually graph this stuff. And so we normally say that five or so at minimum data points. And in here you see there's at least five data points. The more you have, the more accurate your data becomes. Things like repeated data points, like three times if possible. Like we basically do like three different trials of something. And that helps us basically feel like we can estimate possible errors in a more in a better fashion, I guess. And so in here, you'll see we have a number of different pieces of data, and there's enough data that we can actually eventually graph this and see some type of trend. Okay. So when we talk about estimating errors and uncertainty, we want to consider every variable one at a time. So let's say we're talking about time and distance and like those two different types of variables. When we want to talk about the errors, we want to focus on them one at a time. So first thing you do is you list the specific things that could have caused the measurements to be different from each other or from the actual correct value. Okay, so all the reasons, basically, what I say is why or how you could have screwed up the measurements. Okay. And then for each of those, you're going to estimate the total amount that you think you kind of could have messed up in your measurement taking. That's called uncertainty. And when you do this by doing this, when you actually put this data and make it into a graph, it's important to see because if you have a lot of uncertainty or errors in your data, then your data is not going to be that great. And so the less error or less uncertainty we have, the better that data is, the more solid the more solid it is. I'll give you an example of this. If I were to measure my height, I would probably use a measuring tape, right? Um, specific things that could have caused these measurements to differ from my actual height. Maybe I was wearing shoes. Maybe my hair was in like a funky bun on the top of my head, and I accidentally counted that as well. Maybe I decided to wear high heels that day. I don't know. Maybe the person measuring me might have screwed up a little and maybe overestimated or underestimated. So, those are the specific things that could have caused these measurements to be different from my actual height. And then when I say estimate the amount of uncertainty for each of those things I listed, you're going to say, how much in, let's say, centimeters could that have actually affected the measurement? So let's say I was wearing shoes. Maybe my shoe has a sole that's like 2 centimeters like high. And so for that specific one, I'd say, hey, this could actually affect or be an error of about 2 centimeters. And then I say the one, oh, my friend could have measured me incorrectly, maybe by a centimeter. And so all those actually end up adding up. Okay. Um, so that's one specific example. Let's see. Sample error analysis. So, like, I'm looking at something like this, like mass of a wiggly kid at the doctor. Imagine, and I actually do this with my dog. I take my dog to the vet, and she always has to stand on the scale, and it takes her a while to settle down. So she's kind of like this wiggly little kid, where like every time you wiggle, the weight actually changes. So here are your sources of error. That's the first one. The scale ends up not being precise, even. Maybe the scale wasn't like calibrated correctly, which is actually pretty common. That person is wiggly on the scale, so it keeps messing with the mass. Maybe the person at that point has grown or shrunk since that measurement. So maybe like after a certain amount of time, but I don't know, that's an okay one. Let's say I take each of those then. Let's say the scale isn't precise. By how much? Maybe like zero point 0.2 kilograms. The person on the scale is wiggly. So maybe that messes with it by like zero point 0.4 kilograms. And then the person has grown or shrunk. What is that? 0 0.2, zero point 0.4. So by zero point 0.1. And so look, total uncertainty. You add all those types of like possible amounts of error up, and that's your total uncertainty or your total error. Okay. When we start doing this more and more, and especially when we start graphing, this will make a whole lot more sense. Oops, my bad. Forgot about that guy right there. So on here, the data table shows like you take this kid's mass a certain number of times. Do you see that? And so, like, you see that these possible errors could actually come in place where one time that baby is wiggling and moving around on the scale, it comes off as 7.2. And another time it comes off as 7.8, and so on and so forth. And we're done. Here's your summary. Again, how do we measure variables, record our data, and estimate the errors in our measurements? All right. I think my big goal for you guys is to know what errors are, how you measure things, and how you could actually estimate errors. All right. Thanks for watching, guys.